So this is day 5 of our Unit 4B trig unit, and today we're going to talk about angles of elevation and angles of depression. So what you're going to need for this is a calculator of sorts, and then you also need your trig table for this. So these are going to be word problems that deal with angle of elevation and angle of depression. Our essential question is, how can I use trig ratios to solve for the distance of an object that is either above you or below you? So above your eyesight or below your eyesight. So the first one is angle of elevation. So when you see an object that is above you, there's an angle of elevation between the horizontal line and your line of sight with the object. So if you're right here and your object is above you, what I'm saying is when you look up at that object, and also if you consider like the horizon a horizontal line, this creates an angle of elevation. So right here, this would be my angle of elevation. So that's my angle of elevation right in there. And then this would be my horizontal line, and this is my line of sight from me to the object. So on this problem it says Anita, who is 5 feet tall and is 30 feet from her house. If Anita is looking up at the house with an angle of elevation of 42 degrees, how tall is the house? So step 1, the first thing you are always going to do is draw a picture. So we're going to write a reminder. Always draw a picture. Always draw a picture. So over here I have my house and I have Anita. Now one thing it does say is that Anita is 5 feet tall. So I want to add that information on there. So maybe just there to there is 5 feet. Okay. And if you notice up here, I could close this off and make a right triangle. So that's what I'm going to do here. That's how trig comes into play, because I am going to create a right triangle with my line of sight, a vertical line, and a horizontal line. So my line of sight is looking up to the top of the house. And then I need to draw in my horizontal line and complete that into my right triangle. Now it says she's 5 feet tall and 30 feet from her house. So she's standing 30 feet from her house. Her angle of elevation is right here. So we're looking up at the object, up at the top of the house. This is 42 degrees. And we want to see how tall the house is. So I'm going to put my X over here to get how tall this is. So I'm going to label my opposite side. And this side would be my adjacent side. So we are using the ratio opposite over adjacent for 42 degrees. Opposite over adjacent for 42 degrees. I still want you setting up your work just like this. Now, on my left side, I'm going to use my trig table. So if I go over to 42 degrees and opposite over adjacent, that is 0.9004. And then on my opposite over adjacent, my opposite side is X, and my adjacent side is 30 feet. So in order to cross multiply, I'm going to add that 1 underneath. So this gives me something I can cross multiply with. So X times 1 is just X, and then 30 times 0.9004, I have 27.012. So what that means is this height right here is about 27 feet. Now, we do have to take into consideration that we need to go all the way down to the bottom of the house. And so if we look over here, this distance of 5 feet, I need to add over here. So I'm going to take my value, I'm going to actually add on 5 more feet to it to get the total distance of the house. So 27.012. And I still have to add that 5 feet. So that leaves me with 32.012. Now, one thing that is important is that this is a word problem, and we always need to answer a word problem with words. So I'm going to take the question, how tall is the house, and turn that into my answer. The house is 32.012 feet tall. So I'm going to add that information over here. Word problems need word answers. So if it's a word problem, I have some sort of sentence in there about that. Okay, the next one, it says, an archer is standing in a watchtower that is 80 feet above the ground, and the angle of elevation from his target is 33 degrees. How long would his arrow have to travel before hitting the target? So what I want you to do, this is your practice one, I want you to pause the video, draw in your information, and go ahead and solve.